In this video, we're going to look at solving radical equations. First of all, what is a radical equation? A radical equation is an equation that has a variable underneath the radical symbol. So let's remind ourselves of what a radical symbol is. So a radical symbol is a symbol that has a little V-shaped portion with a line. So that's our radical symbol. And we know that every radical has an index. So when we're talking about square roots, the index is actually implied, right? So we don't put the index, but what is actually the implied index that goes in that little V-shaped portion for a square root? Well, that would be a 2. So remember that it is implied. So it means that we don't write it, but we remember that that's what that really means. We've also talked about cube roots. So a cube root is a radical symbol that has a 3 for the index. We also want to remember that when we're talking about square roots, we always have a positive number underneath when we're talking about real numbers, and the answer is always positive. Remember, when we talk about square roots, the answer is always positive. We call that the principal square root, meaning if there are two quote-unquote answers, we always choose the positive of those answers for the square root. Okay, with cube roots, if we take the cube root of a positive number, then our answer is positive. If we take the cube root of a negative number, then our answer will turn out to be negative. Okay, so it's a reminder of what we talked about a few weeks ago when we were talking about an introduction to radicals. So how do we solve a radical equation for x when it's underneath that radical symbol? Okay, well, our steps are going to be to isolate the radical first. So that means we want to get that radical symbol and everything underneath it by itself on one side. Step 2 is we're going to put parentheses around both sides, and we're going to raise both sides to the power that matches the index of the radical. So let's look at example 1 before we continue on with the rest of the steps. In this case, we have the square root of 3x plus 25 equals 7. So in this case, we notice that we do have a radical symbol and we have x underneath it. So this is a radical equation. We also notice that the radical is completely by itself. So we have the square root and we have everything underneath it. There's nothing in front of the square root and there's nothing behind the square root. So when we say isolate the radical, we want the radical symbol completely alone by itself. So there's stuff underneath it, but there can't be anything in front of the radical symbol or anything behind the radical symbol. Okay, so step 1 is actually already done for us. So our radical symbol is already isolated. Okay, step 2 says to put parentheses around both sides. So I'm just going to copy this down to show step 2. We're going to put parentheses around both sides. So parentheses here and parentheses here, completely around both sides. And now I want to know, what is the index of that radical? Well, it's not written there. So remember that a square root has an implied index of 2. So what we're going to do is we are going to raise both sides to the power that matches the index. So we're going to raise both sides, in this case, to the power of 2. Okay, because that's the same as the index of that radical. Okay, step 3, we want to simplify both sides. Okay, so what is 7 squared? 7 squared is 49, so we want to simplify that. Now, what happens when we square a square root? Okay, so there's a long way and a short way to go about this, and so let's just talk about both ways. What does it mean to square something? Doesn't that mean to multiply that thing by itself? So whatever's in the parentheses, we're multiplying that times itself. So when we say square root of 3x plus 25 squared, what we really mean is square root of 3x plus 25 times itself, square root of 3x plus 25. Now we've talked about this. If I'm multiplying two radicals together, we said we can multiply them together underneath the same square root. So what we can actually write is square root of 3x plus 25 times 3x plus 25, all underneath the same square root. Okay, well, what does that do for us? Well, we also remember that if our index is 2 and we have 2 of a kind underneath, we could circle those two things that are matching, that 2 of a kind. We could circle it, cross it out, and we could bring one representative outside of the square root. So we're going to bring outside of the square root 3x plus 25. If there's nothing left underneath the square root, then the square root symbol gets to go away. So the radical symbol is gone. So step 3, we're going to simplify both sides using what we remember from our properties of radicals. Now, here's what we're going to do from now on. From now on, I'm not going to go through all of those steps. From now on, I'm going to go straight from here to here. So when we square a square root, the square root symbol goes away, and what we're left with is just what was underneath that square root. So the square and the square root, so that radical symbol and that power are going to cancel each other out. That's how we're going to think about it. And we're left just with what's underneath. So we're going to use this shortcut from now on. All right, step 4 says we need to solve the resulting equation. So we want to solve this equation here. All right, we have 3x plus 25 equals 49. Okay, we want to get x by itself on one side. So we have an x term here, and then we have two terms that are not containing variables, and this is what we would call a linear equation, right? A linear equation is where the x value in the equation, the highest power that you see on x, is the power of 1. So the highest exponent or power on x is 1. So that means we're going back to the very beginning of the semester when we talked about how to solve linear equations. So we want to get the x by itself, so all the x terms on one side, and then anything that doesn't have an x in it, we're going to move to the other side. Okay, so that means that I'm going to move the 25 to the right side. So we want the 25 and the 49 to be on the same side. So in order to move this, we're going to use that addition principle. We're going to subtract 25 from both sides. Okay, so now we have 3x equals 49 minus 25. That's going to give us, what, 24? So positive 24. Okay, we're going to keep solving for x. So we have 3 times x. We're going to divide both sides by 3. So we're going to do the opposite of 3 times x. We're going to do divided by x. So 3 divided by itself gives me a positive 1. 1 times x is x. 24 divided by 3, that's a positive. Now, before we go on, there's a really important step here. Once we solve that resulting equation, step 5 is really important for a radical equation. Step 5 is not optional. We have to check our answer in the original equation. So our original equation was 3x plus 25. So we're going to do 3 times x. So wherever I have an x, I'm going to put parentheses. So 3x plus 25, all of that underneath the square root, and then equals 7 on the right-hand side. Step 5 requires that we check our answer in the original equation. So what was our answer there? It was 8. So let's check to see if this answer used in place of x in the original equation actually gives us something that's true. So let's check our work. We're going to simplify everything underneath the radical first. So we're using those order of operations. 3 times 8, that's 24. 25, so bring down that 25. Now, the square root symbol is still there. Okay, so still doing that. 49, square root symbol is still there. What is the square root of 49? That is a positive 7. So does that give us something that is true? Is 7 equal to 7? The answer is true. So we have to check our answers when we're talking about solving radical equations. If the answer comes back true, and we add that answer to what we call our solution set. Now, a solution set is basically the list of all solutions that made the original equation true when we replace that number in place of x in the original equation. It's frequently a list of solutions within these what we call set brackets. So we'll put a list of solutions inside of these little symbols that we call set brackets. So all of the answers that go within those set brackets we call the solution set. So those are going to be all the numbers that came back true when we checked our answer. We're going to put all of our numbers within those two brackets.
So we are going to call that our solution set.
Okay. So in your homework, you'll be asked to provide the solution set, and you'll frequently be given already those set brackets, and you're just going to put your answer right inside of those set brackets. So this is what we call our solution set. So it's a list of all the solutions that came back true when we checked, and they all go within those set brackets.
All right, for our next example of solving radical equations, we're going to follow our steps. Step 1, we want to isolate the radical. So that means we want to get the radical symbol and everything that's underneath it by itself on one side. So here's my radical symbol and here's everything that's underneath it. And we see that there's nothing behind it and there's nothing in front of it. So the radical is already isolated. So step 1 is actually already done for us. Okay, what is step 2? So we are going to put parentheses around both sides. Okay, so I'm going to copy this down again. And I'm going to put parentheses around both sides. And the next part of this is to raise both sides to a power of. Okay, so in order to know what power we're going to use, we need to find out what is the index of this radical. So we don't see a number there in that V-shaped portion, so we know that this is a square root, which means that the index is an implied 2. So that's the power that we are going to use. We're going to use the same power as the number of the index. So we're going to raise both sides to the power of 2. Alright, so for step 3 we are going to simplify. So negative 3 squared, that's a positive 9. So remember that's negative 3 times negative 3, so negative 3 times itself. Two negatives multiplied together give us a positive, so positive 9. Okay, remember we're going to use the shortcut here instead of going through all the steps that we went through before. If the index and the power match, so if the index matches the power, which it always will for our problems here, they cancel each other out and what we're left with is just what's underneath. So that's going to be our shortcut. All right, now we need to solve the resulting equation. So whatever equation we get when we simplify in step 3, that's the equation that we're going to solve. And once again we see that the highest power on x is a 1, so we're back to solving that linear equation. Okay, so we have an x term. We want to get that by itself, and anything that doesn't have an x in it we want to move to the other side. So we want x terms on one side, numbers on the other. So in order to do that we need to subtract 2 from both sides. Okay, so that means on the left side, positive 2 and negative 2, we're going to cancel each other out. We're left with x is equal to. On the right side, we'll combine our like terms. What is 9 minus 2? Gives us a positive 7. Now remember, we have to be really careful. Before we decide that this is our solution, we need to check our answer in original. So you can't check it here. Okay, you can't check it there, you can't check it here, you have to check it in the very original equation. So the equation that was originally given to you before you made any changes. So let's check this 7. So I'm going to write down square root, we're going to put parentheses everywhere we see an x. Square root of x plus 2, so that's going to be parentheses plus 2 underneath. On the right hand side we have a negative 3. So let's check that 7. Okay, so we need to simplify everything underneath the square root. 7 plus 2, that's 9. Remember, the square root is still there. Well, what is the square root of 9? The square root of a positive 9. The square root of a positive number is always also a positive number. So the square root of 9, remember we always choose that principal square root, which means we always choose the positive. That's a positive 3. Now on the right-hand side, we bring down that negative 3. Is positive 3 equal to a negative 3? Well, that's a false statement. So if x equals 7 does not give us a true statement, it gives us a false statement, we would call this solution extraneous. Now, it was the only solution we have, and we've determined that it does not give us a true statement. We call that an extraneous solution, which means that it's not really a solution. Well, let's go back up to our steps at the very beginning of the notes, and let's talk about this. All right, so step 5 says check your values in the original equation. If your value comes back false, then that value is not a solution. And we call these values extraneous solutions. And we do not put them into the solution set. So at this point, if we were to draw a solution set, we would have our set brackets for this problem. So there would be nothing inside of it. So we would not be allowed to put in a 7 because 7 is not a solution. And we're only allowed to put solutions within the set brackets. If there's nothing inside of it, then we would say that the set is empty. And there are a few different ways that we can say this. We can say that there is no solution to this equation. We could also say that the solution set is empty because we did not put anything inside of those brackets. The mathematical symbol for empty is to draw a circle and put a diagonal line through it. So when you see this symbol here, this symbol means empty or empty set. It's kind of a shortcut way of mathematically writing the word empty. So you can also see the phrase, the solution set is empty, with that little symbol with the diagonal line through it instead of actually the word empty. So those are 3 choices that you might see when you're doing your homework in MyLab Math. All right, so let's come back to example 2. We have determined that x equals 7, or the number 7, that value is not a true solution. So we cannot put it into our solution set. Essentially, our solution set is empty. It contains no solutions, no values that made the original equation come back true. So we can write this as no solution. Okay, that might be our answer. Or we might say that the solution set is empty. Okay, that's one way. All of these are the same thing. They mean exactly the same thing. Or we could say that the solution set is, and we could use that circle with that diagonal line through it. That means the same thing as the solution set is empty. So sometimes you might see no solution, sometimes you might see the solution set is empty, or sometimes you might see the solution set is empty, meaning using that notation with the circle with the diagonal line through it. Okay, so all these mean the same thing. You might see one or you might see the other, but you need to know that all 3 of those really mean exactly the same thing. There's no solution to this particular equation.
All right, we're going to solve example 3. We have the square root of 4 minus 3x equals x. So we notice that we have a radical equation because we do have a variable that is underneath that radical symbol. So the first step for solving a radical equation is to isolate the radical. So we want to get the radical and everything underneath it completely alone or by itself on one side. So here's the radical and here's everything that's underneath it. You notice that there's nothing in front of the radical and there is nothing behind the radical on that left-hand side. So we have already isolated the radical and that step is actually already done for us. Our next step is to put parentheses around both sides. So I'm going to go ahead and rewrite our equation. Okay, and then we're going to raise both sides to the power of. Well, we need to find out what the index of this radical is. So the index is a little number above that v-shaped portion. If we don't see a number, then we know the index is an implied 2. So we're going to raise both sides to the power of 2. So we'll put our parentheses completely around both sides, and then put a 2 as the power on those parentheses on both sides. Okay, now on the left-hand side, the power and the index are going to match. So we're going to cross those out, and we're going to be left with what's underneath, 4 minus 3x. On the right-hand side, we have x squared. So we're just going to simplify that. We don't really need the parentheses. If we do x times x, then we know we just get x squared. All right, so now we have simplified. Now we need to solve this equation. We notice that this time we have a power of 2 on a variable. So this is actually one of those quadratic equations. We also have a linear term. So we have the quadratic term here, we have the linear term here, and we have a constant term. So we know that we're not allowed to use the square root method if we have that linear term, the x to the power of 1. So our options will be to either factor, that means we're using that ZPT method, or we can use the quadratic formula. Okay, let's try to factor first. If I'm going to factor, that means I need to bring everything over to the same side. So everything on one side, 0 on the other. What I'm going to choose to do is I'm going to choose to bring everything to the same side as x squared on the right. It doesn't matter which side you put everything on, which side you put the 0 on. I prefer to bring everything to the right side because I'd like to keep the x squared, that quadratic term, being positive. Okay, so that's just a choice. So in order to move both of these terms to the right side, I need to use my addition principle. So I'm going to subtract 4 from both sides. Right, and then I'm also going to add 3x to both sides. So I want to cancel everything out on the left and get 0. So negative 4 plus 4, 0. Negative 3x plus 3x, 0. So on the left-hand side, I have 0, which is what I need for my zero product theorem, right? Your first step is to get the 0. Now on the right side, I have these 3 terms, and none of those are like terms, so they have to just sit side by side on that right-hand side. So I have a positive x squared. Next, I'd like to actually list the linear term, so plus 3x, and then lastly, that constant term of negative 4. So we got the 0, and now we need to find the product, which means I need to factor this. So I have 3 terms. We're going to use reverse FOIL. So we're going to do x and x. And then the last is, what do we have? 4. We need opposite signs, right, because it's negative. So let's go ahead and put those in. My options for getting 4, we can do 1 times 4, or we can do 2 times 2. Okay, which is it? Okay, good. It would be 4 and 1. Positive 4, negative 1. Okay, we can check our factorization, always a good idea, by foiling. Let's check. First times the first gives me x squared. Outer times the outer, negative x. Inner times the inner, plus 4x. Last times the last, negative 4. So we check by FOIL. What do we get? X squared, so a positive 3x for the middle, and then a negative 4. And that matches what we see here. All right, so when you factor, I always recommend that you check before you move on to the next step. Make sure you have the right signs. Make sure you get the right numbers, okay? And when you're doing the problem, what I recommend you do is just go off to the side, maybe on the side of your paper, and actually perform the foiling to check, okay? So I'm going to erase it. Okay, so that's out of the way now. We need to continue solving, right? So we have 0, product. Now we need to use the theorem. We're going to set each one of these factors that contains an x in it equal to 0. And now we're going to solve each one of these little linear equations for x. So over here on the left-hand side, I have x plus 4 equals 0. I'm going to subtract 4 from both sides. I end up with x is equal to negative 4. Okay, on the right side, we have the equation x minus 1 equals 0. So I'm going to add 1 to both sides. And we get x is equal to positive 1. All right, so sometimes you might get a quadratic equation, and we need to use our skills from solving quadratic equations to either factor, use the quadratic formula, or sometimes we can use the square root method if we don't have that linear term. All right, so we solved the resulting equation. Our last step is to check their value or values. So sometimes we get more than one value from solving that equation. We need to check all of them in the original equation. All right, so let's do that check. Let's do step 5. All right. I'm going to write our equation out. I'm going to put parentheses everywhere I have an x. And let's first check the -4. So I'm going to put -4 in all the parentheses. Let's simplify the left-hand side and see what we get. Okay, so we have to do everything underneath the square root first. We're going to use order of operations. So that's -3 times -4. We have to do our multiplication underneath first. So that would be a +12. And then our order of operations says we would add 4 plus 12, which gives me 16. And the square root of 16 we know is a +4. We're always using that principal square root. The square root of a positive number is always going to give us something positive. Now on the right-hand side, all we have really is that -4. Bring that on down. No, that is a false statement. So what does that tell me about x equals -4? Well, we'd say that this is an extraneous solution. In other words, it's not really a true solution. So we're going to say not a solution and does not go into solution set. All right, so we're not going to include that in our solution set. Now let's check x equals 1. Okay, so let's write out our equation. 4 minus 3 parentheses equals parentheses. So remember, going back to the very original, scoot up here and see it. 4 minus 3x equals x, and just replacing the x's with parentheses. Okay. Now let's drop in that +1 that we got as a value as well. We have to simplify everything underneath the square root using order of operations. So first I would do the multiplication underneath. -3 times a +1, that's a -3. Bring down that 4. 4 minus 3, that's 1. You still have that square root, so make sure you carry that on down. What is the square root of +1? Well, it's a +1. Okay, now on the right-hand side, we just have a 1. Is a +1 equal to a +1? Yes, that is true. So what that tells me is that x is equal to 1 is a solution, and I will include it in my solution set. All right, so what is our solution set? Okay, so remember on MyLab Math, it will give you those solution set brackets, and you're just going to put in all of the answers that you got that checked out and came back true in step 5. Okay, so our solution set here would be just the +1.
Here we have another radical equation. We have a variable underneath the radical symbol. So when we are solving a radical equation, step 1 is to isolate the radical. So we want to figure out, okay, what's the radical symbol and what's everything underneath it? And here it is. Is that by itself on one side? Well, I would say no. We have something that is on the same side as that radical, but is not underneath that radical. So the radical is not isolated. We want to get rid of this -x. So the -x is not part of the radical, it's actually behind that radical symbol. So we need to get that radical by itself by moving that -x to the right-hand side. So we're going to do that using our addition principle. I'm going to add that x to both sides. So we actually had to do something this time to make that radical be by itself on one side. So -x plus x, those cancel out. So on the left-hand side now, I have that radical isolated. Now there's nothing in front or behind that square root symbol. Okay, now what about the right-hand side? Okay, I would suggest that you be really careful here. These are not like terms, so that means that you are not allowed to combine them. One of them has an x in it and the other one does not. So the best that we can do is we can write them side by side. So that's x plus 5. Okay, I'm going to put a couple of stars here. Be really careful. Sometimes we mistakenly write this as 5 times x. That is not what that is. That's 5 plus x or x plus 5. Not like terms, so you cannot combine them into the same term. So be really careful about what you do with those not like terms. All right, what's step 2? Step 2, we're going to put parentheses around both sides. Okay, so we can do that here. Put parentheses around everything on the left and then everything on the right. And now we need to raise both sides to a power. Okay, what power am I going to raise both sides to? Well, I need to figure out what is the index of this radical. Okay, well the index of this radical is 2. So if the index is 2, then we have to raise both sides to that same power that matches the index. So we're going to raise both sides to the power of 2. Alright, now step 3 says we need to simplify both sides. On the left-hand side, we're using that shortcut again. Because the index and the power match, they're going to cancel each other out, so we're left with just what's underneath that radical symbol. So we're left with 5x plus 19. So that's the left side simplified. Now what about the right side? We want to be careful here. X plus 5 squared. What does it mean to square something? Doesn't that mean we want to multiply what's in the parentheses times itself? Okay, so be really careful here. If I multiply x plus 5 times x plus 5, I have to FOIL. So again, another place, you want to put a couple of stars, you want to make sure that you're careful here. So this time simplifying requires that we FOIL the right hand side. Alright, so first times the first gives me x squared. Outer times the outer, positive 5x. Inner times the inner, another plus 5x. Last times the last. 5 times 5 is 25. Now let's just make this look a little bit nicer because 5x and 5x can combine to be 10x. You don't have to do that, but I think it makes it look a little bit nicer as we move on to the next step. Okay, what is our next step? We want to solve the resulting equation. Alright, we notice that we have an x squared in this problem. So since I have the square, that gives me a quadratic equation. Okay, so what methods can we use if we have a quadratic equation to solve? Well, we can use the ZPT. So that's the factoring method. Okay, we got that. We have linear terms here, right? So we have the 10x and the 5x. It looks like the square root method's not going to work. We could also use that quadratic formula, right? So those are two options. Let's try the factoring option first. So if we're going to use ZPT, then I need to get the 0 by itself on one side. Once again, I'd like to keep that quadratic term, that x squared term, positive, so I'm not going to move it to the left. I'm going to keep it on the right-hand side. So I'm going to move these two terms to the right side. I'm going to get 0 on the left. So that means we need to use our addition principle. So I'm going to subtract 5x from both sides. Now if I subtract 5x from the left side, I have to also subtract 5x from the right side. What's the like term to a negative 5x? Isn't that going to be that 10x? So the linear terms are going to match up with each other, right? So cancel. What about the positive 19? If I want to move it to the right side, we have to do minus 19. And the like term to that would be that constant term 25. So we're going to line up the constant terms, the linear terms, combine those like terms. Now on the left-hand side, I have the 0. Let's combine like terms. I have x squared, 10x minus 5x, that's a positive 5x. 25 minus 19, I believe that's a positive 6. All right, so we have 0 on one side, everything else on the other. Now we need to factor, so we need to find that product. We have 3 terms, so we're going to use that reverse FOIL. We'll do x and x. The signs here are both positive, so we know these are going to both be positive as well. Our options for 6 are 1 and 6, or what, 2 and 3? Which one is it? Yep, I would say 2 and 3. Okay, I'm going to let you check that to the side, off to the side of your paper, but that is correct factorization, and so we'll just move on from here. Right, so our ZPT method says after you factor, we're going to use the theorem. We're going to set each one of these factors that contains an x in it equal to 0. Okay, so now we need to solve both of these linear equations for x. So on the left linear equation, I need to subtract 2 from both sides, so we get x is equal to -2. On the right linear equation, I have x plus 3 equals 0. I need to subtract 3 from both sides to get x by itself. So I get x is equal to -3. Now, are we done? Do we say those are our answers? So you want to be careful here, right? Step 5. What was step 5? Check, right? Not optional. Check values or value. So we got 2 values, so we'll say values in original equation. Okay, you want to be careful that you don't skip that last step. Really important. Okay, so let's first check x equals -2. Alright, so our original equation was square root of 5 times x, so remember in place of x, that's up here I'm putting parentheses, plus 19 minus x. Now that negative x is outside of that radical, the radical ends here. So be really careful when you're copying down that original equation that you copy it down correctly. Now, do I want to write an x? No, I want to put a parentheses in place of x, right? So let's do that. So remember, everywhere I saw an x in the original equation, now I'm putting in that parentheses. Okay, so let's check -2. I'm going to drop -2 into all those parentheses. Okay, we're going to simplify the left-hand side using order of operations. So first I'd recommend that we simplify everything that's underneath that square root. We have to do the multiplication underneath the square root first. 5 times -2, that's -10. Alright, so now we have underneath -10 plus 19. That's a +9. Square root of +9, that's a +3. Now what about over here? What's a -2? Well, 2 negatives give me a positive, so that's a +2. Carry that on down. 3 plus 2, that gives me a +5. So the left-hand side, using order of operations, simplifies down to be a +5. On the right-hand side, we have a +5. Does +5 equal +5? Yes, that is true. So we know that x equals -2 is a true solution, and we're going to put it into that solution set. Okay, so here's our solution set. Alright, now what about -3? Right, we want to try that as well. Scoot over a little bit, and let's try that. So I'm going to copy down the equation again. 5 times parentheses plus 19 minus parentheses equals 5. And this time we're going to try that -3 that we found. So I'm going to put -3 this time everywhere that I have parentheses. Okay, once again we're going to simplify using order of operations. We have to do what's underneath that square root first. Those are our grouping symbols. So we need to look underneath that square root, and we're going to use order of operations to simplify that. So that means we need to look at the multiplication first. 5 times -3, that's -15. We have that plus 19. Bring down that square root. What is -15 plus 19? I believe that's a +4. Square root of +4, that's a +2. Alright, now we're going to finish the rest of the left-hand side. That's -3, that's a +3. 2 plus 3, that gives me a positive 5. So the left-hand side simplifies to be a positive 5, and the right-hand side is also a positive 5. 5 equals 5, that is a true statement. So x equals negative 3 is also a solution. So this time, both of those values came back true when we plug them into the original equation. So both of them are true solutions. So our solution set is going to be negative 2, comma, negative 3. So if we have more than one value that comes back true, then we're going to write our solutions inside with commas separating them. So this is a list of all of the solutions. Now, the order of those solutions do not matter. So if you're typing this into the program as well, negative 3, comma, negative 2, both of those will be acceptable solutions. So both of those would be correct solution sets. All right, for example 5, we want to solve this radical equation. And our first step is to isolate the radical. All right, here we have our radical. This time we have a cube root. So we have the cube root of 3x plus 58. So we're going to highlight the radical and everything underneath it. I see that there's nothing in front of the radical and there's nothing behind the radical on that left-hand side. So isolating the radical, we've already have that step done for us. Okay, so what is step 2? We want to put parentheses around both sides. So we're going to write the cube root of 3x plus 58. And then on the right hand side we'll put our 4. Put the parentheses around. So I'm going to put parentheses around the left and the right sides completely. And now we want to raise both sides to a power of. Okay, so this time what is our power? Let's look at the index of this radical. This time the index is 3. So we're going to raise both sides to the power of 3. So on the top right of those parentheses, I'm going to put positive 3. Okay, we have the same basic principle when it comes to simplifying that we used before. So step 3, we want to simplify both sides. The power and the index both match, so they're going to cancel each other out, and we're left with what's underneath. So we're left with 3x plus 58. So that's using that shortcut again. If the power and the index match, they're going to cancel each other out, and we're left with just what's underneath. Okay, what is 4 cubed? 4 times 4 times 4. 4 times 4, 16 times 4, 64. All right, step 4 now, we want to solve the equation. Now this time we don't have x squared. In fact, the highest power that we see on x here is a 1. So this time we have a linear equation. So this is a lot nicer, that we don't have to use factoring or quadratic formula or anything like that, or square root method. We're just going to get the x terms by themselves on one side, and anything that doesn't have an x in it is going to be moved to the other side. So we have two non-variable terms or non-x terms. Let's move those both to the right side. So I need to subtract 58 from both sides. So that cancels out on the left side, and I'm left with just that x term, 3x. Now I have 64 minus 58. And I believe that is a positive 6. Okay, you can use your calculator for these things. Okay, now we're going to divide both sides by 3. You want to get 3 by itself. So we have x is equal to a positive 2. Okay, now do we just assume that's our answer? No, we want to be careful. We want to make sure that we don't forget to check. Remember, we have to check in the original equation. So I'm going to write cube root of 3 times x, replacing x in the original equation with parentheses, plus 58 equals 4. Now remember, we're checking this x equals 2. So I'm going to put a 2 inside of the parentheses. And now let's simplify. So we have to simplify what's underneath that cube root first using order of operations. Multiplication first. 3 times 2 is 6. So 6 plus 58. Keep the cube root. We haven't done the cube root part yet, so keep that. 6 plus 58, I believe, is 64. Cube root of 64, that's a positive 4. Alright, so we want to know, is 4 equal to 4? Is that a true statement? Yes, that's true. And since that is true, then we know that we can add x equals 2 to our solution set. Alright, so our solution set here was positive 2. Alright, now let's look at our last example of solving radical equations. Step 1. For solving a radical equation, we want to isolate the radical. So we want to get the radical and what's underneath it by itself on one side. So here we have the cube root of 5x plus 9, and there's nothing behind it or in front of it on that left-hand side. So the radical is already isolated. Okay, step 2, we want to put parentheses around both sides. Alright, so I'm going to rewrite cube root of 5x plus 9. And I put the negative 1 on the right side. Alright, so let's put parentheses around completely everything on the left and everything on the right. Now we need to raise to a power of what? Okay, we need to know what is the index of this radical. Okay, the index of this radical is 3. So we have to raise both sides to the power of 3. So to the upper right of both of these parentheses, I'm going to put the power of 3. Alright, step 3 says we need to simplify both sides. So on the left side, we have the cube root cubed. So the power and the index both match, so they're going to cancel each other out, and we're left with just what's underneath that radical symbol. So we're left with 5x plus 9. Right, on the right side, we want to simplify what is negative 1 cubed. So remember, that's the same thing as negative 1 times negative 1 times negative 1. Two negatives give me a positive. So it's a positive 1 times a negative 1. We're left with an overall final answer of negative 1. Alright, once again, really nice. We are left with a linear equation, which means we don't have to factor or use quadratic formula because the highest power that I see on x is just a 1. So we need to get the x terms on one side and the non-x terms, or the constant terms, on the other side. Okay, so 9 does not have an x in it, so I'm going to move it to the right-hand side. And when I move things, we use our addition principle, so I'm going to do the opposite of adding 9, I'm going to subtract 9. To do that on both sides. So those cancel out. On the left side, I'm left with just that x term by itself, the 5x. On the right side, I have negative 1 minus 9. Those are like terms, so I can combine them. If you need to use your calculator, then you can, but that should give you a negative 10. Right, what's our next step here? Going to get that x by itself. We need to divide by the number that's in front of x. So we're going to divide both sides by 5, and we get x is equal to negative 2. So our step 4 there, we solved that linear equation. Step 5, before we decide that's our answer, we need to make sure that we check in the original equation. So I'm going to go back up here. I'm going to write cube root 5 times x. So wherever you see an x, we're going to put parentheses, plus 9. On the right-hand side, we had equals negative 1. So we're going to take that negative 2, that value, we're going to place it inside of the parentheses in that original equation. Okay, now we need to simplify what's underneath using that order of operations. Okay, so bring down that cube root. 5 times negative 2 is a negative 10. We're going to do our multiplication first. When we're simplifying underneath that square root, bring down that plus 9. All right, we got to keep simplifying underneath that cube root. So bring down that cube root. And what is negative 10 plus 9? Negative 1. What's the cube root of negative 1? Now, you could do that in your calculator if you need to, but that's negative 1. Okay, we'll bring down the right-hand side. All right, so negative 1 on the left equals negative 1 on the right. That is a true statement. If we get a true statement, then we know that what we just tested was a solution. So what is our solution set? Okay, we'll have our set brackets. We're going to drop negative 2 into those set brackets. So our final solution, our solution set, is just the number negative 2.